Hello, let's talk today about matrix multiplication, or how I like to say it, you're gonna learn how to park the bus today. Parking the bus, let's see. So suppose I have two matrices like this one and this one. Can I multiply them? Well, it depends on their dimensions. You see, not all matrices are compatible. You cannot multiply all matrices by any matrices. Depends on their dimensions. So matrix multiplication, the order of the matrices matter. Okay? So let's see. This one here has two rows and one column. It's a 2 by 1 matrix. This one here has one row and three columns. Can I multiply them? I have to compare the number of columns of the matrix on the left with the number of rows on the matrix on the right. If they are equal, then I can multiply. Otherwise, I cannot multiply them, at least not in this order. Okay? Now, if this number is the same as this number, I can go ahead and multiply, and I'm going to do that now. The resulting matrix will have dimensions 2 by 3. The number of rows of the multiplication will be the same as the number of rows of the matrix on the left. The number of columns in this will be the number of columns of the matrix on the right, in this case 3. Okay? So the resulting matrix is going to be 2 by 3, 2 rows and 3 columns. Let's see how we make it. So this number, so pretend this is a bus, and here's the headlights of the bus. The bus comes back and parks here. So you go backwards and curve, and then you go here. So it's 4 times 1. 4 times 1 is 4. And then I put the 4 here. Then the bus comes and parks here. So it's 4, and parks here. And then 4 times 2 is 8. Then the bus comes and parks here. 4 times 5 is 20. Then I pick up this other bus here. This other bus is different, it's modern. Then this bus comes and parks here. 3 times 1, 3. 3 times 2, 6. 3 times 5, 15. So that's the resulting matrix. When you multiply this matrix by this matrix, that's what you obtain. Let's do a bigger calculation. Woo! So now this matrix here, 1, 2, 3, 4, is a 2 by 2 matrix. This other matrix here, 0, 1, 3, negative 1, 4, 0, is a 2 by 3 matrix. So this one has 2 rows and 3 columns. This one has 2 rows and 2 columns. Can I multiply them? Always the first question is that. Sometimes you just cannot. But in this case, the number of columns of the matrix on the left is equal to the number of rows of the matrix on the right. So yes, they are compatible. You can multiply one by the other in this order at least. And then you're going to pick up the bus here. So the headlights of the bus, and park it here. Okay, so you pretend you're a bus and you drive there and you park here. So you're going to have 1 times 0 plus 2 times minus 1. 1 times 0 plus 2 times minus 1. Then you pick the bus and park it here. So you drive, the bus parks here. 1 times 1, 2 times 4. Plus 2 times 4. Okay? And finally the bus comes here and parks here. So 1 times 3 plus 2 times 0. So that's how you make this first row of the multiplication. The second one, I'm using the green. So I have to use the green bus. So the bus comes and parks here. So it's 3 times 0 plus 4 times minus 1. 4 times minus 1. Then the bus here parks here. 3 times 1 plus 4 times 4. And finally the bus parks here. So 3 times 3. 4 times 0. Okay, so I have these 6 coefficients, the 6 entries for the product, and I can go ahead and do the calculation. So this is gonna be 0. Let me do the calculation here. So this is gonna be 0, this is gonna be minus 2, so that's gonna be 1, that's gonna be 8, that's gonna be 3, this is gonna be 0. 0 minus 2 is minus 2, 1 plus 8 is 9, 3 plus 0 is 3. And the same for the other row. This is 0 minus 4, that's 1 plus 16, that's 9 plus 0. So 0 minus 4 is minus 4, 1 plus 16, oops, no, it's 3 plus 16. Bad teacher. 3 plus 16. So that's why it's 19. And 9 plus 0, it's 9. Okay? So I did the calculations. I multiplied this matrix by this matrix. By the way, if I change the order here, if I had this matrix on the left and this on the right, there would be no multiplication. It's not possible to multiply because this number is different from this number. So you wouldn't be able to multiply. Okay? Now, in general, if matrix A is m by n and matrix B is n by r, you can multiply because the number of columns of this matrix A is equal to the number of rows of matrix B. The matrix on the left has the same number of columns as the number of rows of the matrix on the right. And then the resulting matrix AB will be m by r. Okay? So that's always the case. And if this number here is different than this number, there's no multiplication. So sometimes you can multiply a matrix in a given order, but not in the other order. So the order here of multiplication matters. AB in general is different than BA. Okay? This is important. Almost always AB is going to be different than BA. Sometimes you can calculate one of the products, but not the other. But even when both exist, the results might have completely different dimensions. For instance, if A is a 2 by 3 matrix and B is 3 by 2, can you multiply A, B? A on the left, B on the right? Yes, because this number is equal to that. The result, of course, is going to be a 2 by 2 matrix. Okay, 2 by 2. Can you multiply B, A, B on the left now, and A on the right? A is 2 by 3, and B is 3 by 2. So this 2 equals to that. So yes, you can multiply, but the result now is going to be a 3 by 3 matrix. So this here and this here are different dimensions, right? Of course, AB will not be the same as BA. This is AB is a 2 by 2 matrix. BA is a 3 by 3 matrix. Okay, they're different matrices. Now, what is a square matrix? A square matrix is a matrix where the number of rows and the number of columns is the same. Okay, we have as many rows as columns. So that's a square matrix. But even in the case when you're multiplying two square matrices of the same dimension, AB can be different than BA. Okay? So in general, this is going to be the case. There are a few exceptions, and we can talk about that some other time, but in general, that's going to be the case. So, in formal mathematical sense, when you have a matrix A by a matrix B, the ij coefficient of the matrix AB, if they are compatible, if you can multiply that, will be given by this formula. Okay? So this formula, if you don't understand, it's essentially parking the bus. It's the trick that I did with this nice analogy of parking the bus, multiplying each row by each column. So this, if you are more advanced, you can understand how this works, but if you don't understand that, just think about parking the bus and you will be fine. All right, that's how you multiply matrices. I hope you had a lot of fun. See you next time. Bye-bye.